All right, let's take a look at these circuits here and how we can simplify them and find out everything we want to know about the current, voltage, and resistance. And so here we first have a case where we have 3 resistors in series. They are in a line after another, and so that would be series. And we can simplify series is super easy because the R total is just the sum of the individual resistors. So there's really no work here to start off with. We are just going to replace all 3 with one resistor, and then the math there is just R total equals 100 plus 300 plus 50. And so we can see we can replace 3 resistors with 450 ohms, and then we still have our 9 volts. All right, it's not going to be as simple when we have resistors that are in parallel. In parallel, if we want to replace all 3 of these, what we're going to do there, the rules are a little different, but here, let me first draw it. There we go. We want to turn it into this. And the formula, instead of you just being able to add them up, the formula is 1 over R total equals 1 over the resistor 1, 1 over plus 1 over resistor 2 plus 1 over resistor 3. So not quite as simple in that case, and because people don't like fractions. And so we're going to replace this with 1 over 200 plus 1 over 200 plus 1 over 100. And if you know your fractions, you could make this 2 over 200. And if you do and add the numerator, you would have 4 and keep the denominator the same. All right. And then we want our total. So our total would be 200 over 4, all right, which is 50. So our replacement, this would just be 50 ohms. All right. Well, let's do a little more here because we want to know more information at this point. Let's also find out some voltage. And, oh, I forgot the current. So let's find out the current here. So we know that I equals V over the R total. So if I want to know actually the total current in this, then I would take this, the voltage, which is right there, divided by my R total. So I'm going to take 9 volts and divide it by 450 ohms. And I'm going to get 0.02 amps. Now, where is this? This says it's the total, and that's true right here in this picture. Everywhere in this picture is 0.02 amps. But because there is only one pathway for the electricity to run, that means everywhere in this picture is 0.02 amps. All right. Okay. Now, let's talk about in this case. If we find, let's do the I total here. And the I total would be my voltage, 10 volts. And I'm going to divide it by my total resistance, which is 50 ohms. All right. And in this case, I get 0.20 amps. And so everywhere here in this gets 0.20. But as we see here, if we look at the full picture, here is 0.20 amps. However, some of it goes this way, some of it gets split this way, and some of it gets split this way. Now, when you just look at this, the only thing I would expect you at this point to know is that they're not all going to be the same, but the amount of current that goes through the 200 ohm and the other 200 ohm should be the same because there's the same resistance to flow. And that the 100 ohm having less resistance should have more flow. All right, and we're going to check that out in just a minute here. Okay. Well, we could do it right now. Let me switch colors then, because we're going to add some different detail. So how about we find out this? So what if I want to find out the current in the 200 ohm resistor? What would I use? Well, I equals V over R, but I need to make sure we have the right V and the right R. All right. This, since it's for the 200 ohm, I need the resistance of the 200 ohm, and I need the voltage that the 200 ohm is going to be feeling. All right, what voltage is the 200 ohm going to be feeling? Well, since this end of the battery is hitting here and the other end of the battery is directly connected here, that is like the battery reaching from one end to the other. So the voltage across this first resistor is all 10 volts. And in fact, the same thing is true here, 10 volts and 10 volts. So when you have resistors in parallel, the voltage across each of these sections is going to be the same. All right, so now we can go and put here 10 volts, so, and then 200 ohms, and I find that the current through this resistor here is 0.05 amps. I shouldn't have to redo this again. Do you see for the other 200, it's going to be all the same math, so that's going to be 0.05 amps. And then when I do the third resistor, I see that I have 10 over 100, so there's less resistance, which means I divide by a smaller number, and that will give me more current. In fact, since it's half the resistance, it should get twice the current, which it does. So we have 0.10 amps. All right, and notice what, if I add these all up, because that's what I can do, right? I have 0.05, 0.05, 0.10, and what do they add up to be? They add up to this total. So we definitely can see, I'll just add different colors so we can see it here, that this 0.20 amps, 0.05 went this way, 0.05 went this way, and 0.10 went this way. And when they come back around, they add up back to being my 0.20 amps. So they all come together here so that the current leaving the battery is the same as the current entering the battery. All right, well, what about up for the series? We already said the current's the same everywhere, so yay, but we didn't answer then the other part. So current is easy in series, but voltage is the one that's a little bit tricky. So now we have to figure out the voltage for this case. And we know voltage equals I times R, and we want to do it for each individual one. So what do I need to make sure? If I want to find the voltage in the, here, let me switch colors just to help out a little bit. If I want to know the voltage for the 100 ohm resistor, I need to use the resistance of the 100 ohm resistor and the current that the 100 ohm resistor has. Now the current is the same everywhere, so that makes that part easy. I can just say 0.02 amps times 100 ohms, and I would get then 2 volts. So I know there are 2 volts here. And then we can run through each one. We realize that if this one is 2 volts, then the math is the same. Oh, this one's not the same, excuse me. So then the next one is going to be 0.02 times 300 ohms. All right, and then we get 6 volts. And then my last one, I guess I'll do it over to the side, is going to be 0.02 amps times our 50 ohms. And then we get 1 volt. All right, so we have 2 volts, 6 volts, 1 volt. Notice in series, the voltage that we have is proportional. So because 300 ohms is 3 times the resistance, our voltage is 3 times as much. And then we see 1 volt. And so this side's connected to one end of the battery, all the way on the other side is connected to the other end of the battery. For a total, there should be a total voltage drop of 9 volts, and we see that. There's a drop of 2 volts, then 6 volts, and 1 volts. So one side of the battery is 9 volts, the other side of the battery is 0 volts, and we can see that as connected across. And we can, again, contrast that to the parallel circuit, where all 3 resistors were connected to both ends, and therefore they all got the 10 volts. All right, okay, hope that helped.